Hi, everyone. Welcome to Unfiltered Flow ELSC. I'm Megan Cook here with Alan Burdett. Today, it's our pleasure to welcome Mr. Chuck DiVincenzo to the show. He is Vice President of Sales at Bucher Hydraulics. Welcome, Chuck.
Yes, I am. Welcome to you guys. Happy to be here.
Chuck, why don't you start by telling us how you got into the fluid power industry?
All right, here we go. I got in the fluid power industry, and by the way, I've been in the fluid power industry this month for 45 years, and got in and actually never left it. But I started at a company in Wheeling, Illinois called Fluid Power Systems. This was not too long after I graduated from college, and realizing that if I wanted to get into outside sales, a friend of mine gave me some good advice. He says, find a good company that you can learn their product and learn it on the inside out. So I got a job in customer service, and I responded to an ad in the newspaper. Wow. Which is what we used to do. Nowadays, it's not like that. So after a series of interviews, I was hired, and I was a customer service person there for about maybe 6 months. Then they moved me to technical support. And then about a year or so later, they moved me to outside sales and major accounts and things like that. I was there for about 8 years, and that was my entry into fluid power. Holding a job back then for 8 years seemed like a short time. Nowadays, it's you're a veteran if you're any place for that kind of time. Not long after that, I went to work for Vickers, and I was a Vickers person for 10 years, Parker for 18, Sun Hydraulics for about 4.5, almost 5. I did a short drive-by with Dan Toss for about 1.5 years, and then I've been with Bucher. Very soon it'll be 3 years. So I have not left the industry, been in it for a very long time.
Well, in all of that time, Chuck, I'm sure you worked on a lot of projects. So do any of them stand out? Do any of them stand out to you? Something you enjoyed?
Generally working in industry and fluid power and having wrenches in your hands or schematics and all of that's kind of fun, kind of. But I will tell you that working in a zoo on elephant doors is probably the coolest thing I ever did. I had a short stint at a company in San Diego, and we had an opportunity to repair some elephant doors at the San Diego Wild Animal Park. And these doors would stop a freight train. And they were designed to swing open and closed. And they had a series of gates throughout the large corral for the big elephants. And by the way, they were very big. And they would have to move them from place to place. And some of them always didn't get along. And they had problems with the doors closing properly and locking. So we got called in. I was a service supervisor at the time. We got called in to figure it out. Long story short, I spent 2 days full time working on an electrical panel, a relay circuitry. Now I'm a fluid power mechanical guy. Mechanical is my background, but this was electrical. So I had to figure out why these actuators were not working correctly and the elephants were pulling the doors open and close. Because the doors would close and they would have enough strength that they could pull on these doors. And these are big steel grates, stop a freight train. They could grab these things, pull them, and just bend the cylinders at the bottom. They just bend them. So the doors had these notches in the end. So when it came across the wall, this big steel pin came and locked the door in place. No matter how hard the elephant pulled, he'd have to take the building down to get it to move. They weren't working. They'd work for a day and then they'd burn out. So I was able to, after 2 days, do an exhaustive report on it and say, this is the problem. You have to change the wiring. There was a relay issue. So I went through and fixed all that. Ultimately, the contractor who put that system together was sued by the San Diego Wild Animal Park. And because of the work that I did and our company did, we documented that it was not our problem. They were trying to blame us for it. It was an electrical issue, not hydraulic. So sometimes you have to reach across the aisle and say, look, I don't have a hydraulic problem. We have an electrical problem here. And that worked out. In the meantime, got to meet the elephants, and that was kind of cool. Don't mess around with them. That's just my advice here. If you ever come across one while you're at Walmart or something, don't mess around with them. They'll let you know who's boss. That was the fun thing. One other thing, if you have a moment, I'll tell you about another not traditional fluid power type of thing. It's not like I was working on a tractor. We got a service call to work out at the airport, and some of the jetways at the airports right now they have two, I'll just call them ball screw drives that raise and lower the jetway to meet the airplane. This one particular jetway was built, and it had hydraulic cylinders in it. And every time they would move this thing, it would leak, and it would leak, and it would leak, and they couldn't figure out where it was leaking. So we went out there. They had a crane. We lifted this, and they had to shut the gate off. They lifted They left the cylinder out. We put it in the back of a pickup truck, took it to the shop, and we realized that the cylinder was defective. There was a weld that was leaking real bad. We ground it off. We re-welded it. We tested the cylinder, and it was that thing had to have a 10-foot extension on it. It was a big cylinder. But way out, came back, pressure tested it, no problem. We brought it back out to the airport, but a few days later, installed it. It worked great and never heard from him again, which was good. We did a fun job. So hydraulics is you can run into elephants in airports and come up with all sorts of fun things that we've done in the industry. It's not dedicated to something in plant, or it's not dedicated to working on a tractor or an excavator. Those things are kind of fun too. If you ever get the opportunity to operate a customer's equipment, do it. You'll learn something. Had the opportunity to work alongside a major OEM, and they took me out to their training grounds or their proving grounds, and they let me operate everything they had out there. Excavators, graders, backhoes, road rollers, a lot of fun. And by the way, operating that kind of equipment is 100 times harder than it looks. People think, oh, you're just digging. That stuff is hard. So if you have an experienced operator, those guys are very skilled. They're very skilled. So those things are not easy to operate, and they're dangerous. So I learned a lot about just how things get used, which is also helpful in fluid power.
Yeah, I think one of the toughest things I ever did was have you ever operated a road grader?
That's the hardest machine to run.
I'll tell you
the hardest
what,
machine to run.
You have to finesse that thing. I don't see how those guys do it. It's just absolutely amazing.
I tried it and I made such a mess. It's like, how do these guys do this? They have like 11 handles on it. And you're right, that is, and I asked them about that and they said, that's the hardest machine to run. An excavator's a little easier. A tractor's a little easier. That's the hardest thing to do. I know.
Well, that industry's in the same situation as fluid power right now, adept heavy equipment operators, right? It's an art form, and a lot of those folks have retired or are on their way to retirement, so they're in the same shape here as the hydraulics industry overall.
Yeah, and I think in the old days, guys would learn kind of on the job, so to speak. But now I think with training and certification, insurance requirements, and union requirements, you darn well better know what you're doing when you climb on a $300,000 or $400,000 piece of earth moving equipment. You need to know how to run it, how to stop it, and if there's a problem, how to fix it. But yeah, it can be horrifyingly dangerous if you don't know what you're doing.
Think about the crane operators. Remember the guy we met in Memphis, Alan?
Yeah, I do. Man, that was something else.
Yeah, that's scary business. They get paid a lot, but rightfully so. 1 inch the wrong way, and you could seriously hurt some folks.
Well, I can tell you one more quick story if you have a minute. This was when I was with Parker. We got called out to Warner Robins Air Force Base because there was a crane there that one of the outriggers was leaking, and they were blaming our valve. So we went out there with some product, and we couldn't get it to leak. We put the old valve back in, and I was able to isolate that part of the circuit and take something apart. So if it was leaking, I would see the oil coming out of where it was alleged to be leaking. It was not our problem. It was something else. But it's easy for somebody to get blamed. And as we were working on it, it started raining. So we had to move the crane inside an aircraft hangar and work on it there. And we had to be very careful because there was an F-15 next to us with a sign on it, 8.5 by 11 sign on it, and it said, please do not remove any more parts from this airplane. So we weren't going to steal anything off of that, but we did get the crane working. I can't tell you what the solution was. It was a while back, but it wasn't our fault. It wasn't our product. But this is where you have to kind of jump in, get inside the machine, inside the bone of the machine, inside the head of the machine, and figure out what's going on. A good machinist will tell you to know if the machine's running right or not. He'll tell you that you need to get in the hole that you're drilling. Then you'll know if it's working right. What kind of noise is the machine making? Put your hand on it. Old guys will put their hand on the machine and tell you if it's running right or not. So
yeah, what's the vibration?
There is some art to this. Yeah.
I think that's a part of the industry too that's changed also. I think not as many engineers that are coming up now really want to get their hands dirty and under a machine and in a machine and really dig deep to, figure out what the problem is there. So I think it's interesting. I think there's the older generation, I guess, that's how they figured things out. And that's why they're such adept, sales engineers and sales leaders, right? Because they were all about hands-on and touching and really digging down in to see how the machine works and how to service and repair the machine. And I think it makes a world difference from hands-on to what do you see with the advancements in smart technology and IoT now?
No, there are all kinds of things developing in the industry, and I think answering this question kind of covers what I was going to say in the last one. But you will have people, students, guys and gals working on equipment, and you're beginning to see fluid power more and more in colleges and universities. It's creeping out of tech school. Tech schools are great. They give you good hands-on experience. If you go through mechanical engineering or mechatronics, it takes you to another level. It takes you to a little bit more analytical space. And what you get then is people who have the ability to dive into a machine, inside it, and look at the brain. You can't touch your car anymore unless you plug it into something. And machinery is like that now. It has telemetry. It has constantly monitoring all kinds of things, fuel consumption, leakage, noise, horsepower efficiency. And if there's a problem, the computer picks that up. That doesn't necessarily mean it's easier to fix. It's sometimes a little bit harder to determine what is that computer really telling me. So the ability to bring electronics and then communication off the machine, telemetry, to a site is important, and it will also give you predictive failure. So if you see a machine in the field that starts to run hot, fluid's running hot, coolant's running hot, or the coolant levels are low, reservoirs are low, sometimes you miss that if you're an operator. And now the machines are telling you, hey, wait a minute, stop. I need some coolant. I need some oil. I need some gas, whatever it is. Machines are getting smarter, and the people on the other ends are getting smarter, and the operators are very talented these days. They have to be. Machines are expensive to run by the hour, by the minute, and a good operator gets the job done quickly, and a bad one never does it right anyway.
Well, something that sort of goes hand in hand with that, Chuck, and that's, we always want to keep abreast of the latest developments, what's going on in the industry. So for those that are trying to do that, what skills or areas of knowledge should they focus on to be most successful over the next 5 or 10 years?
Well, I guess it depends if you're looking for a mechanic, if you're looking for an engineer, if you're looking for somebody who wants to train in fluid power, or somebody who wants to design and create fluid power products. So there's different disciplines, I think, when you pursue those things. Good analytical, solid model CFD folks are really good at the analytical and designing a particular product for a particular application. And the bone in their head is not been cultured to be a fluid power applications person. That's a little different part of the brain where you got to start to put things together to make a circuit or a system work, whether it's a small pilot manifold you hold in your hand, or 12 by 12 by 24 steel block full of 30 cartridges in it. You better know what you're doing there. And there are guys that do. I'm afraid we're coming up a little short in that side of the world, that side of the market, in that part of the application area. Those guys are getting scarce. They're getting old, and we need to bring more people into it. And we have to channel them into what area of fluid power do you want to be in. You want to design valves? You want to design circuits? You want to be hands-on? You want to be a technical engineer at a customer? How are we building this machine? Is it working correctly? What is good? What does good look like on this machine? And so forth. So there's a lot of options in this business, depending on what you want to do. You're not just a valve and fitting guy anymore. You have to have technical skills, and you have to know how to follow circuitry, and you have to understand machine dynamics and forces, all of that cool stuff. So those talents are out there. I don't think fluid power was getting them. I think robotics was getting them. I think computers were getting them. I think civil engineers got them. Fluid power is kind of a hidden thing. I think we used to call ourselves the hidden giant. And it's really a lot of fun. It's an industry where you can do engineering work, and you don't have to be a mechanical engineer or a PhD or anything like that. You just got to have that good bone in your head that allows you to do that kind of work. And I think the industry has not blaming anybody, has not up until recently put together a strategy to bring people into the business. It's educating people as to what fluid power is and where does it go. That is part of what NFPA is starting to work on and has been working on. And I think they've been doing a good job, but the process moves, and it moves at a pace. But as we continue to add machinery and infrastructure and construction to the planet at an ever-increasing pace, it requires more equipment. That equipment needs to be designed and built and tested and validated. One of One of the significant things about hydraulics over electrics is it has power density. I understand electric machines, they have their place, but if you're going to do significant construction work, electrics right now have not made the technological leap to be in the field for 4, 5, 6, 8, 10, 12 hours a day and start it up the next day. Bringing a fuel truck is a lot easier than trying to charge a battery. I don't know how you do that. And I'm all about electrics. I think it's a cool idea. But right now, the power density, the physics are preventing some of those things from becoming a reality in larger horsepower dominant equipment. If you have a very small loader or a small piece of equipment you want to run it electrically, that's cool. That's cool. There's some of that going on. You get into the much larger equipment and it gets a little bit more difficult. The machine gets bigger, heavier. Make no mistake, we're going to see it. We're going to see it as battery and motor technology improves in the ability to recharge and work off the grid. That's cool. I like it. This is a very minute. It's still tough. It's still tough. But I encourage anybody working on it to keep after it. Don't stop.
I think you probably already answered this, Chuck, but I'm going to ask it anyway. What do you see as the biggest challenge in fluid power right now?
One other thing I can add to all of this. Over the years, I've taught fluid power. I've taught product. I've taught this technology to anybody who would listen to me. And it was kind of fun. We always had a good time teaching people. But I told them a couple of things, and let me concentrate on cartridge valves for a moment. I told them, we're going to go through these horrifying cutaway drawings to show you how these cartridge valves work. And they're going to roll their eyes, oh man, here we go. And I said, look, if you're working on something or you're designing something, if you don't understand clearly how that particular cartridge works or how that valve works, you're going to make a mistake. If you're on a machine trying to fix something and you don't understand how that cartridge works, you're not going to be able to figure out the problem on that machine or that vehicle. So we would go through those horrifying examples. I said, something simple like a check valve or a relief valve, how does it actually work? You need to know these things, because otherwise, if you don't, you won't know how to fix something. It's like a mechanic who doesn't know how a carburetor works or a fuel injector. What's that? You got to know these things. Fluid power is the same way. The answer is not going to come flying out at you. The other thing I teach people, and fluid power is full of all of these integrated and circuit equations and integrals and all that cool stuff. And I said, look, I get it. That's a great design tool. I said, but you can solve pretty much every hydraulic problem on a vehicle or a machine if you take the time to figure out force is pressure times area. Use that formula and you can solve pretty much every problem you come across. Now, if you have a component dynamic issue, that's different. That's application related. If you're working on something and it's just not working right anymore, it's force pressure times area. And figure out where all of those things apply in that vehicle or on that machine. What's it doing? What's the dynamic? And it is solved by force pressure times area. And I proved that to a guy who had a, 45 or 50 foot ocean fishing machine. And if you've seen the show Deadliest Catch, it was built like that. And I spent a couple of days down underneath in the engine room trying to figure out why his overhead lights kept dropping out. And it turned out that the system was designed correctly, but nominally there was no allowance for volumetric or mechanical efficiencies in the system. So it was always coming up just a little short. So we fixed it with a calculator. And we did the calculations and we said, based on all the efficiencies that you have here, you're running out of horsepower. The guy says, wait a minute, I have two 800 horsepower diesels down there. Doesn't matter. I said, you're running out of hydraulic horsepower. We made a change to the motor that was driving the generator to change the displacement, a little bit more torque, more flow, same pressure, and away we went. We didn't have a problem. But there were a number of people trying to figure that out. And we just get the calculator out. What's the displacement here? What's the displacement there? What's the RPM? What's the flow rate? Okay, got it. We fixed it, never heard from him again. So again, the basic principles will apply. Again, that's another fun thing I did, by the way. So it's fishing boats, airplane jetways, elephant gates. It's all out there. It's all out there.